I love a jigsaw puzzle, but it can be a real bummer when some of the pieces are missing. Completing it becomes an even more daunting task, doesn't it? Researchers and data analysts often grapple with a similar challenge, missing data. In this video, we'll explore some of the ways that we can handle missing data in our analyses. Hi, I'm Matthew Courtney, and here we talk all about education research and data. If you're into that, be sure to subscribe to this channel and come be a part of our community. Missing data is a pervasive challenge in research and data analysis. When crucial information is absent, it can skew our results and lead to misleading conclusions. Addressing this issue correctly is paramount to your success. Before we can address missing data, let's first talk about the 3 reasons why data may be missing in the first place. The first type we'll discuss is called missing completely at random. This means the reason the data is missing is totally random. It doesn't relate to any other specific characteristic or other data. Think of like names being randomly erased from a class attendance list. It doesn't matter who the students are or any other details about them, they're just gone. Next, we have missing at random. This might sound similar to missing completely at random, but there's one key difference. Here, the missing data is random based on other information we can see. For example, younger people are less likely to answer survey questions about their retirement planning, but we know their ages, and so we can account for that missing data because it relates to something that we know, their age. Finally, there's not missing at random. This type occurs when the missing data is related to the reason that it's missing. For example, people might not report high incomes on surveys because they don't want to share this information with the school. This can make it tricky because the missing data, high incomes in this case, is directly linked to the missing values themselves, and we can't see this information just from the data we have available. Now that we've talked a little about why data might be missing, let's talk about some common methods for dealing with that missing data and when you might choose each method. First up is list-wise deletion. Think of this as the most straightforward approach. You simply remove any observation that has missing data. This method is best when the missing data is minimal and missing completely at random, ensuring that removals don't bias your results. It's quick and easy, but can lead to significant loss of data, especially if many entries are incomplete. Next, we have a technique called mean imputation, where missing values are filled in with the average of the known values in the dataset. This method is useful when the data is fairly homogeneous and when you can assume that the missing values aren't very different from the average. However, it can artificially reduce the variability and potentially bias your estimates. So it's often used when a data set is large enough that the mean is a good estimator and the stakes for precision are not that critical. Moving on to regression imputation, where things start to get a little bit more sophisticated. Here, you use relationships between variables to predict the missing values. This method is particularly useful when the data is missing at random and the variables are highly correlated. It helps preserve the relationships among variables better than mean imputation, but it can introduce bias if the model assumptions are incorrect. Finally, there's multiple imputation, which involves creating several different plausible values for the missing data, analyzing each completed data set, then combining the result. This method is one of the best options when the data is either not missing at random or when the missing data mechanism is unknown, because it addresses the uncertainty inherent in the imputation process. It's especially appropriate in complex analysis, where maintaining the integrity of the data's statistical properties is crucial. Each method has its place depending on the nature of your data and your analytical needs. The choice should be guided by the amount of missing data, the pattern of missingness, and the importance of maintaining accurate and reliable statistical properties in your specific analysis. If you found value in this video today, make sure you like and subscribe and check out some of the other videos in this playlist. I'll see you next time.